Okay, well, as with the 7.1 video, I did teach 7.2 in class. However, it's useful to have videos at your disposal. So here's a video that you might want to review to learn about how to solve systems of equations with substitution. Because here's the deal. I could do this with graphing, but I don't really want to because it's way harder than it needs to be. So let's talk about making substitution steps so that we don't always need to graph these lines and look for their intersection point. Take a look at what I have here. I have two equations. I'm trying to solve for the xy pair that will make both of them work. But I have x by itself. That means wherever I see an x, since x is equal to 17 minus 4y, if I see an x, I could just as easily write 17 minus 4y. Therefore, let's look at the second equation. I could write it as y equals x minus 2, or since x is equal to 17 minus 4y, I could take out the x and I could put in literally 17 minus 4y. Now, why is this a helpful thing to do? As it turns out, you can't really solve an equation with two variables, right? Like if I'm trying to solve this for x, I can't get an actual answer. Or if I'm trying to solve for y, I can't get an actual numerical answer because there are two variables. But by making this substitution step, now I have an equation with just one variable, y, and I can find the value of y. So if I add 4y to both sides, giving me 5y, and if I combine the like terms 17 minus 2 to give me 15, y, after I divide by 5, is clearly 3, which is half of my answer. And I found that by making a substitution step. I need to make a further substitution step to find out the x. Because now that I know that y is 3, anytime I see a y, I could just as easily write 3. So let's take this y of 3. I could put it into either equation. I just feel like doing the top one. Not sure why. Bad math pun. Not sure why. Did you get it? Did you get it? Did you get it? I hate math puns. They're like literally the worst. Anyway, when replacing the y with the 3, now all I need is 17 minus 12, which is 5. So x is equal to 5, and my point is 5, 3. Very, very easy to do a substitution step. As always, you can plug these back into the equations just to make sure it's true. I'll do it for this one, but not the other ones. Here, if I replace the x with 5 and the y by 3, like is 5 minus 2 actually 3? And yes, it clearly is. So this answer works in our first equation. Also replacing the x by 5 and the y by 3, well, that's what I just did. 17 minus 12, yes, is clearly 5. So it works in the second equation as well. So that's the winning answer. The point, the xy pair, makes both answers true. All right, yeah, wow, here again, y is isolated, which means that anytime I see a y, I can just as easily write 2x minus 1 because y is equal to 2x minus 1. So looking at the second equation, instead of 2x plus y, I could write 2x plus 2x minus 1. I have eliminated the y from this equation by substituting, and now I can simplify. 2x plus 2x is 4x, add the 1 to the other side, and x looks to be 1. I can easily find y by plugging x back into either one of the equations. Let's put it in up here. So y equals 2 times 1 minus 1. 2 times 1 is just 2, and 2 minus 1 is 1. So it looks like y is 1. And substitution. Easy. Remember what I did. I took this, since y is equal to this, I substituted it in here, and I was able to then solve for x. Let's just do two more examples because, as it turns out, I won't always have a nice isolated variable like I had here. Sometimes there are no variables that are isolated, and before I make a substitution step, I need to figure out which variable to isolate. I have three options. I could isolate this one, or this one, and plug it into the other equation. Now, let's just think about this for a second. Let's say I felt like isolating this x. Like, you can totally do that. You would add y to both sides, plus y, 2x equals 23 plus y. But then, in order to truly isolate x, you need to divide through by 2. And now I'm dealing with fractions. That's just unpleasant. So I could isolate that x, but why make myself do more effort than I need to? If I isolate this x, all I need to do is add 9 to the other side. And actually, doesn't this immediately give me an answer? I already know that x equals 8, because in isolating x, I just added 9 to both sides. There wasn't a y. I got the answer. So when isolating a variable before making a substitution step, just make sure you're being intelligent about what you're doing. Now, I need to plug this x equals 8 in to solve for y. Don't plug it back into this equation. This is the equation we just got it from. If I plug 8 back in there, I have 8 minus 9 equals -1. Obviously it does. That's how I got it in the first place. So don't plug it in there. Plug it into the other equation. So we'll plug 8 in for the x up here. So 2 times 8 minus y equals 23. 2 times 8 is 16, so I need to subtract 16 from both sides, and I have -y equals 7. So canceling the -1 by dividing through by -1 gives me y equals -7. So my final answer, 8, -7. One final example, this one. No variable is isolated. I need to figure out which variable will be easiest to isolate. If I try to isolate this x, I'll eventually have to divide by 5. If I try to isolate this y, I'll eventually have to divide by 2. But if I pick one of these, if I pick one of the bottom equation's variables, all I have to do is subtract, and I'm good. I don't need to divide. Let's isolate the x, just because. You could also isolate the y and still end up at the right answer. If I isolate the x, I get x equals -3 minus y. So now I can make a substitution step. Anywhere I see x, I can write -3 minus y. I'm going to put this into the top equation. Here's what the result is. 5 times, instead of x, -3 minus y. Make sure to put parentheses because it really is 5 times this entire thing, and so you need to remember that I'll eventually have to distribute in. And let's just copy the rest of the equation. So 5 instead of x, y minus 3, or -y, -3 minus y, plus 2y equals 9. All right, I'm down to just one variable, so let's solve. I can distribute in, so -15 minus 5y plus 2y equals 9. Combining like terms, adding 15 to both sides, I get 24. So it looks like y, when I divide by -3, equals -8. I can plug this y back into any of the equations to figure out what x is. This would be an easy equation. So replace the y with a -8. Obviously here I need to add 8 to both sides, so it looks like x equals 5. This represents probably pretty much the hardest problem you would see in the substitution section. Again, make sure you isolate a good variable. Isolate this guy or this guy. Don't try to isolate one of the top two. It's just going to create fractions which you do not want. All right, so in summary, isolate a variable, plug it into the other equation, solve, and then when you have one variable, just plug that answer into one of the other equations to get your other variable. Substitution, it's pretty easy, it's pretty satisfying, but lots of little steps, so make sure you check your work as you go. Thanks.